Today I'm going to make this bottle of Prime go from this to this, while still being drinkable. So a while back I went to my local dollar store, which by the way they should just change the name to $1.50, because nothing's $1. Anyway, I found these bottles of Prime that say charge in the sun and glow in the dark. This naturally made me curious as I spent a lot of time in college doing experiments about fluorescence and phosphorescence. So with nothing to lose, I picked up a couple bottles and figured I'd run some experiments. Now this is where things got disappointing. I thought the liquid inside the bottle was glow in the dark, but it turns out it's just the wrapper on the bottle that glows. Personally, I thought that was lame as hell, but it got me thinking how I can use chemistry to get what I want, which is a glowing Prime hydration drink that actually glowed in the dark. So I started thinking about the chemistry of fluorescence and phosphorescence. Basically, fluorescence is when molecules absorb light at a high wavelength and then re-emit that light in the form of a lower wavelength, as there's always some energy loss due to heat. When photons hit the molecule, it absorbs the light to gain energy that causes the electrons to jump to higher energy levels. At the high energy level, the electron will eventually lose energy in the form of heat and snap back down to its ground state level. As it snaps back down, it gives off energy in the form of light, causing it to appear as though it's glowing. Phosphorescence, on the other hand, is a very similar process, but instead of snapping back down to the lower energy state quickly, the electrons get stuck in the higher energy level. This causes the material to glow even after the light has been removed. Examples of this would be glow-in-the-dark toys, this egg, and that damn Prime bottle. Knowing this, I'm still eager to make that liquid glow while still being drinkable without my free trial of life expiring. The way I'm going to do this is by using tonic water. Tonic water has a chemical inside it called quinine that's fluorescent when exposed to a black light, and it's completely safe to drink, in somewhat small quantities. The molecule quinine absorbs ultraviolet radiation. Electrons get excited and instantly snap back down to their ground state, emitting light in that process. For this Prime flavor, I'm going to make different concentrations with the tonic water. Tonic water tastes like stale gasoline, so I'd like to avoid making the entire drink taste like that. I'm going to make a 5, 10, 15, and 20% solution and analyze them based on taste and appearance under a black light to see which one looks cool but also tastes palatable. So I started with the 5% solution of tonic water, and surprisingly, this one wasn't half bad. It just tastes like a Glowberry Prime. The 10% didn't taste half bad either, with almost no carbonated trash taste in there. Now the 15% is where things started to get bad as the tonic water started to overpower the drink. The 20%? Just throw that crap away. It's absolute landfill water. In conclusion, Luke Paul and PSI should have hired me to create their beverage appearance. I only charge a couple million. If you like videos like this, consider subscribing. Maybe. I would first talk it over with your wife, your accountant, maybe your boss.